looks like it's still working. Let's go back in here. Yes. Okay, that's the way it should be working for you. So maybe there was just something weird going on. Yeah, something it did not like. So since that whole portion of the lecture kind of got destroyed, I'll continue a little bit like this, and then I'll jump into a scene that's got the finished head. It's the one that's on FSO in the example images. We'll do the UVing and the normal mapping, and then call it a day and save the rest of the stuff for the next class. Now remember, if you don't come on Friday, that's when I'll be talking about putting your scene together, doing hair, and it's going to be exactly what's on FSO now. So when you go in there and you see the archived lectures, the week 4 lecture 2 archived one from a previous month, that was actually from not last month, but the month before, and it covers doing hair, looking at hair, and then getting into the submission. So you will have that information. You just need to make sure that you watch it, right? I'm finding a lot of people that were surprised in week 2 that, what do you mean we had to separate our model into pieces? I'm like, well, that's what you're supposed to do, you know, kind of deal. So you have to make sure that you're watching those videos and taking notes on them, not try to follow along. Follow along, it just doesn't work all that well. But, you know, like I said, I'll continue on this a little bit and kind of work from what I have and kind of move through it. I don't know. I don't even know if I want to try the dog, but, you know, we'll see how it goes. So when you're looking again, we finished with the horrible problems. We were establishing the radial for the mouth, right? And really when I'm first getting into wireframe and topology, I want to focus on the main areas of shape change. So if you're getting into this out of the gate and you're like, man, I really don't know how to establish all these edge loops, right? Because what happens is when you put more geometry in there, you start to get confused, and then you start making these loops that are unnecessary and weird. And a lot of people go, hey, what do you think about this junction on the cheek? And I go, why are there 3 junctions right next to each other? And they're like, I don't know, I just needed to work the geometry that way. And I go, well, that's not a good answer. So get rid of it, simplify that area. So if you're looking at your topology and you're going, well, I've got this weird junction, box junction over here, and there's nothing needed for that box junction, like a shape. Box junctions are great for boning landmarks, making arcs or turning an edge loop. You know, if there's really no need for it, get rid of it, right? Just simplify, go simple, throw in extra edge loops, and then space out your geometry, and it usually works out okay. So in the beginning, I might, especially on a basic human face, I'm going to try and target all the major edge loops. Now, this guy, you know, putting in a muzzle loop and then a radial around the mouth is something you really want to have, is that nice radial around the mouth. His mouth is open. A lot of time you're going to be dealing with a character that doesn't have an open mouth, right? We didn't sculpt them that way. We sculpted them with the lips closed. So you're going to have to be diligent and get close into that model, get really up into the crease of the lip, and make sure that you're not merging that section together. Here's why. You want to maintain kill zones on a model, right? Kill zones are areas you can terminate an edge and not worry about it ripping through the rest of the model. So a lot of times I'll notice people go in here and they just want to add an edge loop in. So they'll be like, okay, cool. Make sure I'm in the scene. They'll throw an edge loop in this way, and it'll go through the lip, into the bottom lip, down into the neck, shoot through the torso, around the arm, and around the leg, and it just kind of goes everywhere because they don't have clean edge looping in their model. Or it'll shoot up into the eye, through the head, loop around the ear, back across the face, and they get these bands, right? And they go, I don't have time to fix that, so what do I do? But if you keep a kill zone, I know that the topology I'm going to run, if I drop in an edge here, based on the way I like to edge loop, it's going to go into the eye and into the top lip and be done. It's not going to go anywhere it's not supposed to. So maintain an open slit through the lips, okay? That'll also really maintain your radial. So when you're doing the radial for around the lip or the eyelid, you're going to say, okay, this edge is for the upper lip line. You can see I placed it right on that lip line. It should be the same edge that's making the bottom lip line, right? This is a general rule of thumb. It's not always this way. There will be cases when you change that, but for most of the things that I'm seeing in the models that you're producing, I would just do that. Just say whatever edge is here, I'm going to loop that around and make that the bottom one. Same with the upper eyelid. I'm just going to go around the eyelid and make the same edge as the upper eyelid. It's going to be my lower eyelid as well, right? So it's just kind of a nice way to get into that. But first thing I kind of wanted to look at was a basic edge looping structure. So we'll go into resurfacing, and you know, I got into planning edge loops, right? So when you're planning, you are thinking, you know, on the face, it's a little different. You know, you're thinking about functionality, but I did watch someone back in early 2000s, and they were trying to make an edge loop structure that followed all the major anatomical muscle structures, right, of the face, and it just was a big mess, right? The face is, you want to pay attention to the functionality of those muscles, right? Because you want your geometry to form and be able to be pulled the way the muscles respond or act. But there's skin on top of that, so we're trying to fake the illusion of that skin. So when you're planning on, know where the geometry needs to flow for proper deformation, but don't get too heavy into the muscles. But also pay attention, like, look at this. There's that nice, what is it? I think it's a sphincter muscle. I know that's weird, right? So it's a little different now when you think about winking your eye at somebody, whole different meaning. So you've got that nice radial muscle strap. You've got the muscle strap coming out of the top of the eye through the head. You've got the kind of, it's not really radial, they do overlap. You've got a strap here for the upper lip, and then you got one that goes up underneath. You know, but again, they're in kind of the same direction, same patterns as I'm going to lay out my wireframe. The other thing you can do, right, besides that, is get into Photoshop and plan a colorful chart, right? If you want to get into modeling and you're really thinking about creating good wireframes, good topology, you know, this is part of a way to study and plan, right? You're like, man, I don't know how to run this geometry. Let me go ahead and make myself a little chart. And because we showed you how to do this with the first reads, if you did use the pen tool, you did use the shaping feature for that tool, you'll be able to get in there and make a nice quick shape and create yourself an edge loop pattern. Now, I went ahead, and this is the one I run with, and I've run with it for years. It's a great basic loop structure for a human face, anywhere between teen, once the head solidifies and it's not, you know, because you're talking about infants and younger children, toddlers, their skull hasn't quite gone where it needs to go. So once that happens, this is a good edge loop for a basic person up to when gravity takes over on the skin. Once we start seeing sagging and jowls and things like that, that's when we would need to alter some of this. But this is a great looping structure. And if I'm thinking about making something like this on a basic human face, for the muzzle loop, I know I need 1, 2, 3 edges, and it's done. The extra edges I add in are support edges, right? We know that there's a sharper crease from the skin difference from the top to the lip, right? Once we get into the soft lip, right, skin, it's different. There's a little bit of a crease there. So I'm going to need support. So I would drop in an edge above and below that edge loop. Those are support edges. Up here, we know that this should bulge out a little bit. It rounds. You can see it right here as the gums push on that upper lip. Well, from here to here, I don't have anything to round it, so I would need an extra one, right? Also, we're going to need a little bit of support from the bottom of the nose. So I'm going to drop in an extra one right there. So once I build a basic loop structure like this, I can just drop in edges as needed to hold certain shapes or support deformation or anything like that. So you might want to take this very low res approach in the beginning before you start going all crazy and getting lost and start turning loops, and then it starts making a mess. Simple is sometimes better for this. So if I wanted to build this basic loop and I had an image like this, let's go ahead and make that happen. Let me make sure I've got my reference so I can see it. I only need to see half of that. So I'll keep that like that. It's going to be a little backwards, but I'll make it work. Okay. And since we're in quad draw, I'm just going to go into pro mode. Boop, boop, boop. All right. And, you know, I'm not really going to worry about counting, but I am going to look at where major junctions are. Anytime I'm looking at a wireframe, I want to pinpoint star junctions because they tell me where there's a change in direction. Star junctions and junctions in general, those will tell me some things. So I will keep an eye on those. And if you wanted to count, you literally could just count your way around the eye, because this pattern right here will work on this guy. It will work just fine, okay? So let's go ahead and create this right away. And there is a downside to building this way. If you want to know it, I will tell you. Okay. The downside to creating this way is that because of the use or the way that this tool functions, adding in a higher res loop for around the nostril becomes more difficult, because you can't just split polygon tool, right? Or the multi-cut. You would have to back out of the quad draw tool, activate those, or do that loop and then come back in, or know how to function with this tool to get that shape. Well, what I would do, if you do that, it's going to throw the edges where you don't want it. I need to be able to turn an edge. I'll show you what I'm talking about when we go further from this, okay? So control is good for this, but when I want to turn and make a custom junction, that's where it starts to get a little weaker, right? All right, so I'm going to go in there, and then I'm just going to create this other structure. Let's go ahead and fill in the mouth. And if you want to extend loops, I find that extending edge loops with the tab key works really nicely for certain things, but sometimes it actually is really just problematic, and I'd rather just go manually with it. I think we're missing one. There we go. We're getting a little bit of chop, but much better than yesterday. Yes. Now, the reflection tool, the symmetry tool, does work. Now, why wouldn't I use symmetry on this? Because symmetry doesn't like to create nice center lines, and my computer doesn't like anything more than it needs, right? So now we're talking about it's chugging, it's more for it to think about. So I'll just mirror it over, kind of deal. That's a great question. Why not use a symmetry tool? Also, it didn't work for a long time. The symmetry tool, you'd click it on, it wouldn't do anything. And then one day it was like, no, it works. And so we tried it out. We're like, okay, it does work. But then trying to work the center line, it starts snapping and doing weird things. And you're like, forget it. Yeah. Yeah. And so I was like, you know what? I'll just mirror it over. It's just as fast. Okay. So again, I'm going to keep following this. And don't worry, I am thinking about this extra geometry that's going to be needed for that hard crease. That would be something I'd want to put in here, but I'm going to get a base structure pretty quickly. You can see 1, 2, that is out here to the corner of the eye. Let's go and elongate that a little bit. Start drawing that loop. And then this one goes under the chin. It looks like right about to the center. And if you've got a good hand, you can drop them in like that, where I'm just holding shift and following along the loop. Every now and then, though, that does shoot a weird junction. You see, I'm also draping, right? That's something that I like to do with my topology. No, don't freeze up. No, why?
And you were just praising mine, weren't you?
Well, and somebody asked me a question about the symmetry tool and just threw it all off. There we go. It just took a little bit for it to recognize that. Yep. And, it's just a real quick kind of solution. So now we're going to go side of the nose. Now I'm directly referencing what's happening here. I'm going to need an extra one. And I'm going to use extend, but I want to use awesome. I don't even know what extend feature you put to. Why is it not giving me my marking menu? Okay, I'll just do it manually. I'm not worried about it. Looks like it's 1. And then from the center, we go over 1, 2. Where did my other one go? There we go. Now remember, this is a very basic structure. This would not fly as an end-all be-all wireframe. I'm just trying to follow, reference, and create the geometry that I'm seeing in my image. Please don't do that again. I'm just kidding. So don't forget, always do a little bit of maintenance. Get in there. If you see something coming off spacing, if you see an edge getting away from its target, take the time to put that stuff back. Okay. Now I can't see what's going on here, but I know, because I did build this one, that there is another star junction in here. I just have to figure out how to get it. There we go. It's the top of the nostril. The one that I'm referencing was built out of a plane, just a regular polygon plane. And it actually started right here with that, a 2x2 plane, and I started extruding and doing certain things with it. So looks like I need to do, I'm just going to go ahead and kick that one out because this should be closer. And there is a different one there. There we go. Being a modeler and watching movies, I remember putting in this purple loop right here out of the corner of the eye because I was watching something with Mel Gibson in it, and he had that type. You can definitely see a crease from outside of his eye and it went down the side of his face. I was like, might want to plan something for that type of structure. So the tab should work okay for this. And I will relax a little bit. Okay, you can see that where that star junction is, we need, and then I'm going to use extend again. I want to see if I can get the extended. Yeah, it's doing something, but it sure isn't wanting to give me exactly where I need it to go. That's okay. That's all right. We'll let it do its thing. Oh, you're going to chug a little bit. Okay. Please don't. Not that. Just drop it. Just drop it. 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 We'll drop that one. Let's see. The older you get, the more sounds you make when you move. Okay, so let's go back to something where it's going to, I don't know. This is aggravating. Ooh. That means that was an alarm for a time to pay attention. Yeah. I'm just kidding. Hey, it did something. My point disappeared. I hear something. I don't even have, because they don't want us to have the latest and greatest. Just dropped it.
Oh, no, she was not home.
Yeah, I mean, it usually doesn't do anything like this. It's all that, I think it has to do with the go to training and the fact that I don't even think we have internet cables anymore. So we're going through the Wi-Fi and all that other stuff. Come on. It's actually the past couple months has gotten really bad, which is why I think things are about ready to catastrophic failure. I need to grab one of my hard drives and back everything up. Did you let go finally? Oh, you're doing some other stuff? Okay. Yeah. Yeah, it's one thing. When I was a student, I'd be so quick to just shut down. And I learned that, give it a little bit of time. Sometimes it'll come to. Sometimes. Yeah, sometimes it'll be like, nope, sorry.
You just lost everything. Bye.
It's not even letting me. There we go. Hey, I think it freed up. Yay! Let's delete history. Come on. I just want to go to, just give, no, what are you doing? There we go. There we go. See, but doesn't it feel good? We deal with the same stuff, same crap. But you know what? I still got to get my stuff done. So. Yeah. Well, did you do this?
Yes.
Let's delete some history. Okay. That was weird. I deleted history and it's going to shut down on me. What? Okay. So anyway, I'm not even going to look for the crashed version, but I will bring this one up here. This one should have some of that already done, because this is a great, getting that basic loop structure is a good idea, but you will struggle trying to rework something like the nose. It is beneficial to go a little bit more complicated around the nose, and that geometry would almost triple in amount of density, right, to get a finalized version. Gotta let it open up here.
Do you have any examples of what good topology would look like on like a long muzzle feature?
I could probably find something. If not, okay, flash. There we go. Oh, gonna save everything's better. Hey, it's at 2018. I might need to, because it's becoming annoying.
Have you tried unplugging it and plugging it back in?
Yep.
But did you like wait a minute?
Well, I think they force some stuff like that. So you can see here, this one a little bit further along, still following roughly the same wireframe. We looked at this one earlier, but I want to show you that. Remember that the nose that I was referencing was nothing more than a blocked nose. It was just a blocked out nose. This one here, though, I'm following the topology. I'm actually creating the fold. I'm running topology around the nostril, kind of holding that. Yes. Yeah, what indents? This one? This one? This one?
Yeah, I'm pretty sure there's a line in Maya.
This one? No.
Right below it is like. Or no, see, because Maya wasn't rendering the line.
Oh, you guys are seeing it different. Yeah, but mine, it looks super clean up there. It's all.
Some of the lines are gone.
Yeah. So you can see here, I've got a little bit of tear duct in there. I've got a holding edge for the eyelid. I'm not doing an eye bag or closing off the eye hole. I just kind of keep that open. I'm also not compensating for any of these masses here. I'm kind of keeping that simplistic, but still following larger shapes. So when I hit the 3 key to check this geometry out, I should still feel silhouette changes. So if I look at this at different angles and things like that, I should still feel those mass changes. So when I do an evaluation of how is your topology holding the shape, which it's coming from, you know, I want to be able to still see some of these large masses. The displacement map or the normal map, it'll take care of some of these smaller things, right? It'll get those really nicely for us. So I don't want to put in a whole bunch of crazy topology. 6 years ago, it would have been a different story, but now I can get away with something a little more simplistic. So some people go, well, how do I know if I'm looking at a low res polygon image, if I was looking at, say, the one I had up earlier, how do I know how, you know, what kind of geometry would work around the nose? And you don't want to just localize, right? Try and remember what the other one looked like. There were some really big polygons, and you can see it here, right? This is not going to cut it. This is too low res. We're shooting for a density similar to this one here, okay, right about this. All right, so this would be a starting phase, just establishing that. One, it's done, right? If all you did was this, at least it's finished. But would it score in the A or B range? Maybe not, because it's still very low res. So we want to pick it up a little bit more and add some of the supports. So what you can do is, if you did go this route and you weren't building it all on the fly, you get into Google and you say, all right, let's see, topology for human nose. Did I get human nose? So here you've got images, close-ups, and you might find some other stuff. So now when people go, oh, I couldn't see in your picture that you had, I can't see what the shape is supposed to be. Well, find a close-up. You can do this for an eye, a mouth, and you have to be careful though, right? Because you might find somebody who just started making topology, it's their first go around, and they post their image, and you find that and you go, oh, that looks good. But if you run it through the 4 rules, right? Who remembers those 4 rules? Raise hand. I want to see somebody raise their hand and say all 4 of them. Come on, who can give me the 4 rules? Raise your hand. I'll pick eye, and then you give me the 4 rules. Yes. Okay. Well, it's not just about shape being good, and it's not just about clean lines. There's more to it. What are the names of them? Can you give me the names, or not really names, but a better idea of what each one of those means? Okay. What about the shaping? Well, end guns, you don't want to have any of that, but that falls under a larger umbrella of an idea, right? I said there was 1, 2, 3, and 4. And there was a lot of talking in between those, but there were 4 main categories. Yeah.
Shape, form, clean spacing, even spacing.
Is that 1 or is that 2? Yeah.
I don't know.
Even spacing. Because I remember you saying that topology should hold the form.
Well, yeah, you that's part of it. I'm just looking for the exactly how I laid them out. That's what studying's all about, right? Yeah, remember, you're talking to somebody again back in my day. I would go home and read my notes. And then before I'd go to bed, I'd read my notes again. And then I'd wake up and I'd read my notes. And then I'd come into school about an hour early, and anybody that sat next to me knew they were getting quizzed or they were quizzing me, because I wanted valedictorian, right? I wanted to make sure, yeah. Oh, yeah. So that's why I wanted to teach. Now, it was different, though. That's a great question, because my friend Jeff, who worked on Hobbit and King Kong and all these other great movies, he failed a lot of his classes. But what was the difference? My goal was to teach. His goal was to make a lot of money and be famous. So I wanted to, I felt it very important that because I wanted to teach here, I needed to show them that I knew everything inside and out, troubleshooting, everything they told me. You know, I can regurgitate where little sliders were 3 subsections down under a tool. That was important to me. That's where I wanted to be. So that's why. Valedictorian really doesn't mean much, because I've seen a lot of people not get valedictorian and do amazing work and do amazing things. So grades for me was about my goal, right? So anybody got those? Looks like I'm not giving away a pair of sunglasses. Okay. So basically, you're going to be looking at the 4 rules. So you've got density and parameterization. Okay. That's where we look at the density of the model, making sure that we're nicely moving from a lot of geometry to not so much, but we want to make sure that also we've got nice amount of densities throughout the model. You don't want the eye to be packed with 100,000 polygons and then the cheek have 10. It's just not going to work. You want nice gradient changes. Parameterization is the measurement between the components. So I have a square, nice, even, unified parameterization, or is it a bunch of rectangles and kites and torn topology? Shaping is the topology I'm making capable of achieving the shapes I need, right? So you could be building topology. I see a lot of people throw this blanket grid over the front of the face, and they don't put anything in for the nose, and it just, as soon as I hit the 3 key, I lose all that information, or if I smooth it, I lose all that information. So their geometry they're using does not fit the shapes they're trying to create. So it just, the topology is no good. Or they have extra topology, too much topology in an area, weird junctions and funkiness going on, and it causes shape discrepancies. So we get a pucker, a pinch, something we don't want on the surface because of the topology. The other one is, do we have good clean topology in general? Right, all the stuff that we learned in 3DF and MCR, non-lamina faces, no reverse normals or non-manifold, right? Unmerged verts, n-gons, too many triangles, heavy star junctions, all those basic kind of ideas in our topology. And then the other one, edge looping and edge flow, right? Are you using edge loops correctly? And do you have the going to the clean edges, clean flowing edges? Do they look all erratic like a heartbeat, or are they nice and smooth and moving through the model correctly, right? And that comes into your ability to use edge loops, right? If you look at an image like this, they're using edge loops. It looks nice and clean. It's moving with the geometry. It's not all erratic and jumbled up. So those are those 4 things. So when you're looking at your topology, when you're looking at reference for your topology, you should be able to answer those questions, those 4 things, and go, okay, cool. Now, some of it you won't be able to see. You're not going to be able to go, well, is this lamina faces? Chances are, though, if they've got their settings right, you will see it, because lamina faces are faces on top of each other. So you'll see hatching and weird flickering and stuff like that. Non-manifold geometry will show up as that, like almost like a black hole, right? There's just completely zero shading information on it. Shaping wise, you look at the model and you look at the shape it's creating and go, okay, that looks good. So obviously that geometry is holding what it needs to, and it's capable of generating the nice shape. On something like this, you look at it and go, okay, that geometry is okay, but that shape needs some work. But it's not really a fault of the geometry, it's just the shaping. But you'll see some models where the topology is terrible, and you can see that they're fighting with the shapes, right? Like this here, this is way too, there's no need for this. This has good shape, so sometimes it's confusing. This has decent shape, but man, that's just way too, yeah, it's just, now this could be really old. It could be new, it could be, I don't know, but yeah, it's this would be an example of just overcomplicated. They've got some nice stuff. Here's the nose loop, the tip of the nose looking really good, but then you get into the side of the face and it just falls apart, right? They don't have a clean radial pattern for the eye. They have density issues throughout. The geometry looks a little erratic. So their edge loops are broken, right? This right here falls short on a lot of those ideas of good topology. So it's complete, right? If I were to be grading it, it's complete. There are some good things in there, and I can see that they're kind of getting it. It might be a C to a D, right? If it's complete and it's done, it's probably not going to get enough unless it's complete garbage, right?
That's just one big polygon.
Yeah, I mean, I've seen some bad stuff where somebody's like, I need to get this done. Click, 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 and they literally have like 10 polygons. And like, I'm like, that's not going to work.
Hey, but it's complete.
Well, then I give it a 30, a complete 30. No, I'm just Hey, I had somebody once. We asked for 3 different things, and they didn't give me the one thing that I can evaluate, but they had the second thing, which meant that they had to have done the first thing. So we gave them a 0 in the first category, and then they argued, and then my boss was like, but they couldn't have gotten to step 2 without having step 1. I said, but I need step 1 to make sure, 1, they're not cheating, and 2, because I asked for it and I need to evaluate how they started. Yeah, but and I had to give them credit. I had to evaluate what it was. Well, and they just think about what would be fair. How could they have gotten here if they didn't at least get a 70 or 75 on step 1? And I'm like, okay, and that's when I learned, give some points for something, kind of deal. Yeah, education's a strange thing nowadays, but the what?
So they make sure you pass everything.
No, I mean, it will, as far as grades go. Let's say somebody's not a modeler, and I probably shouldn't be talking about this on the video, but if somebody's not a modeler, yeah, it's kind of, to stand in that way. I mean, granted, when you're learning, you should try your hardest in everything you do. And I can tell when effort's being put in and when effort's not. And even if somebody passes, people are like, but what if I worked really hard and they pass the same and they shouldn't pass? Somebody that's producing bad work but is passing a course, that you're not going to work for them, right? When they get into the industry, it's going to show that they can't produce certain types of work. So, yeah, I don't really ever worry about that, kind of deal, that thing of
For the most part, if they want to make that kind of work, they put the work in.
Yeah.
At least they should.
Yes, exactly. So I'm not saying if you try, you're going to get passed or anything like that. I don't do that, but yeah, and it's kind of one of those, if you're not producing good work, you're not going to get a job. So what difference does it really make? 3DF is a tough class. Yeah. Yeah, I was talking to somebody today, and they were really trying to utilize our Google Hangouts, and I go, do you ever see anybody in there? And they're like, no, I go in there several times, and I just never see anybody there. I'm like, yeah, that's a hand. Oh, this is a cool image. Look at this one. It's even how to build. Oh my God. This is a nose from a cube. But if you ignore that and you think about how to draw in your polygons on your quad draw, that right there is a run through of how to do that. Oh, here's a mouth. Starting with simple loop, adding in some extras. This information is out there. Here's good topology for a lizard face, which has an elongated muscle. No, I'm just kidding. That's
not really.
Yeah, that's terrible. But let's look at let's see, topology for dog model. Here's some good topology for a dog model. Let's take a look at this one, see if this one's decent. It's got some interesting stuff here. It looks like they're really trying to hold that fold, but overall the idea is pretty clean. Good density, good parameterization, good edge flow. Some of the looping here might be a little bit awkward, but you see the muzzle going up and over the muzzle, sweeping in. I like that because it answers that question that I had the other day. Well, if you have a small area here and you're trying to bring that geometry back and you've got a larger area here, they're answering that by sweeping into the upper lip, so that works out. Here's a more simplified version. Let's take a look at that one. Not too bad. Still has a radial for the mouth, radial for the nose, radial for the eye. Getting a little stretch. It looks like this might be being viewed in 3 mode or a smooth version of it. What we're seeing, the base cage. Some of this feels like it might, if I were to go to 1 mode, might feel a little stretched. So the addition of an extra edge or 2 might help alleviate that pressure. This one feels, you can almost feel like the geometry is kind of pulled and stretched here, and again, being viewed in 3 mode. Whenever you see something that you can't see the faceting in, be careful of that, be mindful of that, because that is a smooth version. So when you see this topology, if you feel any stretching or pulling or weirdness in that edge flow, it's going to look worse when you hit the 1 key, right? So may not be a problem with the topology, but might be something where you go, okay, well, I'm going to need to add a couple extra edges to hold that. Oh, that's cool. That's a fun little character. The geometry is a little bit stretched now. Oh, here's someone laying at this. Cute laying at the. That's kind of an interesting The problem with this one is because you can't actually see the muzzle. I don't mind this topology here and around the eye, but you can't really see how the from the upper lip, from right about here to back here, going up and over the muzzle. You can't see the depth. This is a very common issue when people are shaping heads. I don't know how many times when we were building in Maya and we didn't have ZBrush or whatever, how many times I saw foreheads pulled out to the line of the cranium in the back of the head. And I'd be like, you don't see a problem with this? They're like, well, no, it looks, I matched it up to the reference. I go, no, that's the back of the head you're seeing. You got to think about foreground, midground, and background within your image. So your forehead is in here. Here's your temple region, and then it slopes back to the back of the head. So with something like this, they're drawing wireframe and they're missing that element, that depth within the image. But I do like the parts they can see, the eye and around the nose. That's actually looking pretty good. So hopefully if they worked on that further, it would work out. This one here too, low res. That's like a very low res game model.
Yeah, I guess it's,
yeah, this one's pretty clean. I don't like those. When I look at something like this, I go, all right, because you might be like, why don't you like that? Well, one, it's a triangle next to a kited polygon, pretty close proximity to a box junction. I would have rather have seen this open up and run this edge one through the forehead, just continue this edge through the forehead and continue this one up into the ear. That would have been a lot cleaner and simple, and it would have helped with the overall density of the model. Do you see what I'm talking about? Let's draw on it. Let's do it. Let's mess up their art, yes. So what I would do is I would continue this edge up and into the ear like it is, okay? I would continue this one with it. And then this one just opens up and goes through the forehead. And if we're doing any kind of animation, we'd want that geometry there anyway. So it takes away that need for this weird junction and it throws an extra loop. Remember I said, anytime you're getting rid of a junction that is condensing geometry or a star junction, you're getting rid of one of the legs from a star junction, you're going to end up with more geometry, and it's usually an edge loop running through somewhere. This one here, I would have probably done the same thing. I would have either just collapsed it down. Because we're adding in this extra one here, we might be able to collapse that, but I don't see why we could continue that one like that and either turn this one down the side of the face or just run that one. We could just run it and spaced out our geometry a little bit more. Now they do have some weirdness here. I am noticing, I'll tell you what I'm talking about. Because they didn't really build a nice radial pattern around the ear, we've got some randomness here. But what I would recommend if anybody's doing an ear like this, take your geometry up and around and back down, and then you can run a box junction to hold that, and it'll create a much better flow for the model. Right, you can just do something like that, and then you can run edges up and then back down, you know, kind of deal. But I can tell that that top of that ear is a little bit wonky. This bandit, it looks like they tried to bring in what we call the bandit mask, right? The bandit mask is an edge loop that goes top of the brow, around the eye, and up over the nose. For this type of model, I just don't know if that would have been the best choice. You can see it right here, sweeping around and over the mouth, yeah, like a little bandit mask. It looks like it's working out okay. I think though, because of the density I'm seeing here and in other places, right? You can see here we got a lot of geometry, but like a lot of geometry going this way, but not too much going this way. I would have added one or two extra edges here and there and kind of spaced them out just to help the overall density throughout the model. It's actually pretty cool because we're going through and bring it. So you can see here, again, this is in 3 mode. How can I tell? I can't see the faceting. So I can feel a pull right here. It's kind of pulling. So in 1, that's going to be even worse, right? That's a red flag. It's something I want to look at. So what I would do to help that is throw in probably 2, maybe 3 extra edges through. If the edge loops are correct, those will just go up underneath, right underneath the chin and to the other side. So I would do that. And then because I added extra ones there, I might throw an extra one in here. Not that one, right next to it, and then move this one over so it flows better. And then possibly an extra one here, an extra one here that runs down and around, and maybe an extra one up through the head. And that's going to bring an overall better feel to the density changes throughout the model and just help out with some of these that are starting to get rectangular and help them kind of just relax a little bit and become more uniform, right? This one here is a little stretched. And by adding in one extra edge loop over the nose and down into the lip, that allows me to move this one over a little bit this way, which relaxes the tension right here. You can see that that star junction in 3 mode is already a little pulled. In 1 mode, it's going to be worse. Let's see. Oh, let me get out of this. Let's see if we can go. Oh, this is master project. Okay. Let's see if we can't get that a little bit. Oh, no? That's weird. Is there just a head one? Cool. All right. So you can see this right here. All this geometry is starting to feel like it's melting. It's pooling a little bit, right? Not pooling, but pooling. So that, again, in 1 is going to look worse. And I would want to add in something to help alleviate that pressure. If someone was yanking on my arm, it would hurt me. So if you see polygons being pulled, it hurts them as well, right? Give them a voice. Hear them. They will speak out to you, right? Now, they are doing some weird stuff. This is going to, anything like this where I don't want to say weird, but they're doing some specific stuff for the teeth and the gums. One of the things, again, always to be thinking about is, should I build this together or separate? If they were to have built the gum structure separate and actually created the lip, right? Because the lip is going to be sitting over the teeth, right? Not right onto the gum. So we'd have more depth there. If you build those separate, because you're never going to see this, you're not going to grab the lip and pull it to see the lip connection to the gum. I can build those separate, and what that's going to do is it's going to allow me to forgo any weird geometry around the mouth to compensate for the weird geometry within the gum area. So building those as 2 separate entities might be a beneficial move. I like the geometry in the neck. I think overall, a couple little tweaks, and this would be a pretty solid mesh, right? It's doing an okay job. Just a couple little additions might be good. Ooh, look at this one. Wow. They're asking quite a bit. So when we talk about erratic, let's look at this one. That's right. That's what you need. Mm-hmm. Yeah, no, I mean it could be the rig that doesn't allow. A lot of people go, when you go like this, that's a tough motion to get. One is because a lot of riggers will rely too much on the shoulder, but you'll notice that as soon as you bring your arm up to about here, rotation starts to happen at the clavicle, and this whole area rotates up. That's how you get above your hand. So what'll happen is, as the arm comes like this will twist. It'll just flip around because it's run by an IK system, inverse kinematics, right? So you have a handle here, and as soon as we go here, it doesn't know what to do, so it wrings out the shoulder like a wet towel. And you know what some of the answers is for that? Shoot from a different angle so we don't see it when on time, right? So I did an animation. We like to test out curriculum every now and then. So there was a class, they did a tennis serve and hit. And so you throw the ball up, and as soon as the racket comes up like this, the arm would just twist. So all I did was I shot it from down here. So the head blocks the shoulder discrepancy. I don't have to worry about it. But yeah, in some games, when you rotate the camera, it's either a rig problem or the geometry just isn't there to support, right? So in this one here, the biggest issue that I would say if I was gauging this or grading it, awesome, or in somebody's art station, you guys would be like, so my teacher went into your stuff and tore it up. Do you have any more pictures? Okay. They don't. All right, well, I don't know where that other one came. Is it somewhere else? You see it? Oh, forget it then. But basically, do you notice anything within this? If we look at it here again or whatever, do you notice anything that feels weird, feels off?
That's hard because the line between myself. Projection.
Okay, but you see how nice and even this looks? And then you get into the ear.
Yeah, because it
right? So, can I save images? I'll save to my desktop. Now I've got this model. Let's see. Right, so we have all this stuff looking nice. Now the ear becomes less important, so, but look, there's some really wonky stuff going on in there. Okay, and you can see over here.
That's why they got it put it there.
Could be. Now, this could just be a visible thing where there's two surfaces really close together and Maya or whatever program this was built in doesn't know what to do, so it shows the wire. This happens in ZBrush all the time. You get cross-hatching and weird stuff. But when you get stuff like this where the geometry feels nice and then all of a sudden it's starting to tear, it starts to kite is what they call it. The edges, you know, it's erratic. And what could have helped out would have been relax and maybe a couple. So here we've got a model that looks really good and has a lot of good stuff going on in the wireframe, but you know, something's going on in the ear and it could have just been a weirdness. It could have, I don't know the artist. It could have been, you know, maybe just a temporary thing where they fixed it and they're like, oh yeah, don't worry about that. But these are things that when you look at a model, you look at wireframes, you look at other people's stuff, those should be red flags because one of these things is not like the other. Can you point it out? Yeah.
What do you think about like the
This?
bottom of the nose, basically?
I think it works out because there's more, whenever you have more detail in the surface, it's going to require more geometry. And so what they're really trying to get is that nice lip line. I think that works out. And they're really putting in a holding edge for the nose itself. So it does work out. It could have been smoothed a little bit more, but that's, again, starting to get nitpicky. These ears just jumped out at me as, whoa, what's going on there? And that's really all it is. They could be completely fine. And in a render, you're going to render it probably twice as dense as it is, if not 3 times as dense. So if it looks good, then it's okay. You have to have, you know, situational viewing, right? What am I looking at? If I'm pulling wireframe reference, I need to start asking myself, those feel weird. Is it something I should worry about, not worry about? Is it going to be okay? Maybe I have to do a test, right? So modelers that think you don't think you have to know how to rig. You have to know how to rig enough to do test binds on your work. Test binding is you throw a quick rig in there, you move it, you try and achieve certain poses or do certain things, and if it works well, it's going to be okay, right? As long as it works up to about 70-75% of what the rigger might need, you might do a quick test bind. You might test out blend shapes for the face, all that kind of stuff. But I just want you to see that you can get online and there's a lot of information out there to be had. Right, here's one here. Ooh, what's going on there? I don't like that. I'm not like, oh God, what? The ear just feels puffy. And this is an example of unnecessary junctions. There's no need. I'd rather put those in the neck as we condense out of the face into the neck. But this right here, what is that doing? Why not just run it over the nose and hit another one in the eye? We can totally simplify that area. I don't know the age of this image, so we might be looking at something that, you know, it might be a background character, and at that point, how nitpicky do we have to be? Right? There was a great, I think it was the Flip Normals guys that were talking about retopology and how important is perfect topology nowadays, because we have the computing power, we have vector displacement maps that get us these nice volumetric shapes at render time. And they talked about, you know, background characters. I might just let ZRemesher do whatever funkiness it's going to do, and it's a background thing. Who cares? If it's a hero character, I really do care. I need to make sure that it's 100% what we need, right? So again, there's a lot of stuff going on there that you need to think about and kind of, oh, kitty, you know, kind of go through all that. Yes. What is that?
Are you pretty sure it's a cat? What does that human legs? Like, especially the back leg.
Because they kit bash some IMM leg brushes from ZBrush.
Oh, it's just as bad.
Yeah. But you see kind of how you can start looking at topology a little bit more in depth and really kind of thinking about it and going from there. Just find yourself a good one, though. Don't make this harder on yourself, and do a little bit of research. Get out there and check it out. All right, so we're going to go ahead and switch gears from topology and look at UVing, right? We're gonna go ahead and get into some UVing. And I'm just gonna show you how easy it is. It's a super quick process, right? And we'll go into that. And that's, and we'll go, I think it's under resurfacing. Nope. It's 2016. Let's see if I've got a new one. I think it's this one here. And you gotta be, you know, when people are looking at your stuff, you gotta be comfortable with it, you know? Comfortable with people checking out work and tearing it up. Okay, so here we've got the asset. Now I'm gonna start it off exactly how you're gonna see your work. I'm just gonna go ahead and delete these UVs. So you're gonna go ahead, this would be your scene with your bust or whatever that you separated from your model, and then it's got the resurface topology on it. So you can see this is an example of the finished product of the human face. You can see the density, we're sitting at about just under 2,000. We've gone around the ears, base of the neck, under the chin, a decent layout with a nice resolution, not too heavy, definitely not too light, cartoony or whatever. This would be a nice resolution I'd tell you to start shooting for. If your character has more volume, your poly counts will be higher. If it's smaller, it might be a little bit less, but like I said, around 2,000 is going to work out okay for this one. All right, so now it's time to do the UVs and normal maps, right? I know a lot of people hate UVs, but again, I'm going to show you a process super quick, super easy, and we'll be ready to go. So I am going to delete history. Okay. Make sure that if you are working in your resurface scene, that you take the make live off of the high res. We don't need that anymore. But we're going to grab the low res, the resurface topology, and this is what we're going to UV. So right now it currently has 0 information. That's because when you quad draw, right, it doesn't create any UV information. If you did, you know, I catch a couple resurface heads that have like a crazy mess of UVs, and I kind of go, did you use a quad draw? Maybe built it some a different way. But if you start using the regular tools, you might start getting some UV stuff showing up over here, and it's going to look like a pickup stick mess, right? We got to make sense of that. So the first procedure, whether you're trying to clean up all the craziness that has been created from modeling, and you've just got a big scribble mess over here in your 0 to 1 space, or you don't have UV information, we need UV information. So first thing we're gonna do is just a planar map, really quick planar map. I'm gonna pick the best angle of approach since the front of the face is the most important. I'm gonna shoot it from that. Now, if I had a dog head or something like that, I might shoot it from the side, because it's going to give me cleaner UVs from the side. I might shoot it from the top. You know, I might play around a little bit and see. UV is so quick that if you got to do it a couple times to get a better result, then do that. Okay. And I would also get online and find a UV layout. Just like we looked at wireframes, we can look at UV layouts and say, is this a good one? Is it a bad one? Please don't pay attention that we are working on just a head, and that's all we're worried about. So I'm going to try and maximize my 0 to 1 space with just a head. So I'm going to do something here that you normally won't see, and that's a 45-degree turn on the UVs to try and maximize 0 to 1. Your 0 to 1 space, that's where all your pixels live. And if you waste that information, you are wasting pixels and resolution for a texture. So we always want to try and eat that up as much as possible. But first steps, let's go ahead and just give it some information. So we just hit apply, done, there we go. Next step is know where your seams are supposed to go. The unfold tool, the smooth UV tool, they do not know what to do unless there are seams present, right? So did you see that picture people were posting that was like the little Santa candy chocolate with the wrapper unfolded? And it's like, this is exactly what UVs are, right? That's a great example. The other way you can look at UVs is think about if I were to try and take a bunch of flat material and make a 3D form like a teddy bear or something like that, wherever they cut the seams to fold and sew back together to create this 3D shape, that's kind of like what we're doing. So if you're kind of like, I don't really understand the connection between the UVs and the model, just $1, buy yourself a cheap little stuffed animal if you got some around, rip the stitching out of it and lay out the pattern and go, that's UVs, right? Yeah, murder that little thing. I always thought about it also like skinning something, right? I've got a lot of doctors in my, yeah. Well, I have a lot of doctors in my family, and I remember being a little kid and walking around the corner up in Bear Creek, up in the mountains of Pennsylvania. Well, they had a fox, and they just gotten their doctor's scalpel tools and everything, and they were skinning a dead fox that they found on the road. And they go, hey, you want one of his feet? And I was a little kid. I'm like, sure, let's do this. So they gave me some of those pruners. No, we had to throw it away because it started to stink. I didn't know anything about, I mean, I was a little kid. Yeah, you know, but you know, it's the way you pelt something is exactly the way you might think about UVs. Where am I going to make incisions so I can peel the skin off? It's kind of gross, but think about that as you're looking at it. So I'm going to do a cut through the back of the head across and kind of create a football goalpost, and that's going to allow the head to unfold and unwrap exactly the way you need it. But have something, find reference. There's a couple other ones. A lot of people like the incision straight from the hairline back, and they let that unfold. I'm not a fan of that one because if you're ever going to do the bald character or anything like that, it makes a lot of, even if you paint on the model with Substance or any of those other programs, it's a lot of distortion because you're really trying to pull all this skin and lay it out flat, and it just, trying to put that back together doesn't work. So I like this one. You may not. Totally fine. I'm not going to hurt my feelings. It might a little bit. Or blood face or whatever that. So I'm going to go into edges, and I want to turn on display polygons and turn on texture border edges. It may not. Yep, you don't need the ears. Not on any, unless you have like the big bunny ears and there's not a lot going on in the face. I'd recommend doing that. Remember, making it worth the grade. Some people are like, well, I don't have a mouth on my character, so I didn't do the ears either. And I'm like, well, it kind of feels incomplete, you know. But on this, we're gonna be modeling the ears. So they're all good. So I'm gonna go ahead in here and just make sure that I turn on display. Now, why do I want to turn on texture border edges? Because it tells me that when I make a cut or when I sew UV edges together, that it actually worked. Otherwise, you're kind of like, I don't know what's going on. Did it work or did it not work? So that's what I'm going to do there. Nope, I didn't want to go to faces. We're going to go to edge. And we're going to go ahead and start making the cut. So we're going to go from the back of the head, right, wherever the center is. There's the center. Let's make sure we have the right one. Up to about, we'll give that a shot. That looks good. Okay, and then I'm going to go 5 over. No magic number. I'm just like to keep it somewhere around the temporal crest. So we'll go 1, 2, 3, 4, 5. 5. Your numbers will be different. And then we're going to go from here to the edge that is right there. We'll do the same thing over here. Okay, we have that. Let's go to the UVs and cut. And you can see that now we can see those cuts. So now I know that it's happened, it's good. Okay, if you have a lot of geometry underneath the chin, sometimes we can hide something here. You don't want to go too far up. Raise your hand. You might see that seam there, but I'm just going to cut more seams. Huh? Now, if you've got anything like, let's say you did close off the mouth, this one is not closed. You can see that it is open, separated. That was a pain in the butt to do because the model had that open like that. I had to kind of a lot of hand positioning geometry because the lips are actually overlapping here on the corners to get that fleshier feel. So that was a nightmare. I don't have the nostrils closed off, right? Keeping those open, just going up enough to get some depth. This is not what would be considered a watertight model, right? It is got openings, and you can see the eyelids, same thing, just kind of. But if you do have those capped off, and you do have the nostrils should be okay, but the eyelids or the eyes inside, you might want to separate that and lay them out and put them off to the side somewhere. Same with the mouth cavity. If you did put in a mouth cavity, separate around the lips on the inside and put that somewhere else. Yes. A lot of that stuff gets modeled separately. Yeah, so, and then if I need to connect it, I'll connect it at that point. But yeah, the mouth cavity and mouth bag is what it's called. Yeah, it usually be different. Yeah, so the nostril, you just pull up as high as you need, unless there's a discrepancy. Because after that, it's just a nostril, right? You want to be able to put the bandana up there and then pull it out the other side. That's what everybody needs to do. All right, so we got that going. Once you cut those seams, you could unfold. All right, this is how literally how easy this is. I'm going to go ahead and put the color on there, showing the front and back side of the UVs. I'm going to grab all my UVs. I'm going to go to Modify, Unfold. I'm going to make sure I'm on Unfold 3D. This tool used to not work, and I stayed away from it for a long time. About 6 months ago, someone was like, no, it works really good now. So I gave it a shot, and I was like, well, that's what we're showing. It's so easy. Unfold 3D, iterations 5. That's how many times it's going to sample it before it gives you your final layout. Happens super fast. You don't have to worry about it. Map size, 2048 by 2048. Online, it's still referencing 1024. If you do it at 1024, that's fine. And we're just going to go ahead and apply and close, and boom, done. But I am going to zoom in on all your UVs. I'm going to see if the corners of the eyes are overlapping. They are not. I'm going to look at the nostrils. I'm going to look at the corners of the mouth and make sure that they're not overlapping, and everything should be good. Okay? But that is literally it. Is that somebody's phone buzz, or is that mine buzz? No. Is it mine? It starts worrying me. I leave it on because I get the kids at school and people traveling, and I've heard it twice now. It's not mine, but it is. That's what seriously, I looked at it. I see two numbers all the time when I check my clocks. I either see 311, which is a pretty decent band, and I don't condone any of that. I'm at 420. Those are the two numbers. I seem to always look at my phone or my clock when I see that. The what? Really? That's pretty cool. Yeah, it's 311 and the other one. All right. So we got this here. I'm going to go ahead and get it to fit inside the 0 to 1 because this is outside the 0 to 1. We're not doing UDIMs or anything like that. UDIMs is utilizing multiple 0 to 1s to maximize resolution. So you'd be using Mari for that, most likely. Okay. And again, I really want to make sure that I get as much space usage as possible. So I'm going to take my time. That's why I did it that way, so it did look like that. Now, you'll notice that if I move a little bit more and I really try and get as much space as possible without destroying. Right, so if I did ears, I've got all kinds of other areas. There's a lot of extra space here. But what I hate seeing is when someone does this, and I guess they're using the layout tool, and their head UVs are way down here. And I'm like, what? You're wasting like 80% of your 0 to 1 space. That is just a terrible way to do it. Yeah, normally the only discrepancy here doing it at an angle is if somebody were to hand paint a texture. Because when you're in Photoshop and you're trying to hand paint that, being at an angle is kind of weird. Yeah, so it's kind of strange. But in anything like substance or anything like that, it doesn't really matter, right? Because I'm getting the most out of that, and it's going to paint fine at an angle. Keeping things vertical, horizontal is important, and you'll know when you're talking to somebody and they're going to be the one texturing, and if you're not, they're going to say, oh, or they should be saying, when you deliver your UVs, do it like this. When I was working with Crash Gem and they were trying to launch their game, they had me UV a bunch of, simple things, and they really appreciated that I grouped my UVs in something that made sense for them, right? I organized them. So I did a feasting table. I did the top of the table all in one area. I did the bench all in one area, and I kept everything vertical, horizontal. And I took time to make sure that things were, where they need to be. And then I gave them a color coding so the texture artist knows this is where the tabletop is and everything. They're like, oh man, that was awesome. Thank you. Well, no, I did it for free just to kind of have some fun. I really like low res. I like modeling in low res every now and then because there's this beautiful thing of trying to count every vertice and make it really count on the model for shape, So when you have to do a sword and a shield out of 1,200 polygons, triangles, you're like, oh man, how am I going to do this? So it's just fun. It's just fun. They needed help, so I helped them out. I don't know if the game's actually ever released or not. I don't think it did. So it was crashing. Cherbils. Like gerbils, but cherbils. Yeah. I don't know if they still have anything. But you can see here, it's super easy, right? What did I do? I planar mapped it, cut my seams, unfold 3D, rotate it, make sure I'm maximizing space in my 0 to 1. Done. It can be that easy. But if you don't know where your seams are going to go, it's not going to be that easy. But if you've got long ears, cut those off separately. If you're dealing with something with a muzzle, think about probably going to split down here and open up the head this way. So if this was a muzzle, I'm going to unfold it like that. So I might cut like this and then let that, because the side of the face is really important. I don't want that to stretch. Kind of just think about that. Now, part of the simplification of this process is having good geometry, because there'll be times if I modeled an ear, a big bunny ear correctly, I'm going to have edges running around the side of the ear, almost right down the middle part. So think about if you've ever worked with old model, the gluing models together as a kid, right? And you build the wing, it's got a mold line right around the wing, and you glue that together. Well, now stand that up like an ear, a big bunny ear, and you can see that we want to think the same. We want to have that nice edge, center lines. Remember me talking about center lines? The arm should have a center line, nice, clean. The ear's going to have the same thing around the outside and up through the front and to the back. It's also going to have a nice radial from where it came from the surface. You're going to make a nice radial. If you don't have those nice edges, you might have what is called a jogging seam, right? So let me save this. I'm just going to save it. Do I have the resurfaced version? I might. Oh no. Let me see. It's going to be on it. This might have it. Let's see. Okay. Oop, get out of there. Didn't even try to go to that. So for this model, I wanted to see how usable Z-Remesher would be, and it did a terrible job for the face. So I basically redid the entire face, and then I had to fix some of the weirdness through the center line. It really kind of messed up the center line. There was some wonkiness there, but for the most part, it did an okay job. But because I'm not familiar, I don't have a straight line running through the side of the body. You'll notice I had to come down and then through the back of the arm, which isn't too bad. But you can see here, there's not a clean line around the inside of the lip, so I had to jog over, right? And then really what is terrible are the hands. So here, because again, I let Z-Remesher, and this is why Z-Remesher kind of falls short every now and then. If I were to do the hand, I would make sure that I had a nice clean edge running through my hand, through the side of the hand in each finger. So I can just separate upper and lower. I can do a nice layout like this, kind of deal. So with this one, I didn't have that. Each finger literally has different topology. So you'll see this one, I had to go up, around, and then down. I had to jog down to the center. This one here going up and over through the nail bed, a little jog in the middle, another little jog there, right? And that's a problem. That is going to cause me some issues. Now, it is hidden in here, right? So unless I do any close-ups, it's really not gonna be a problem, but it made laying out the UVs a little tougher. I had to figure out where those things needed to go. And if we want to look at his UVs, there they are. You can see the hand laid out over here and the body. Looks like I need to move that down because we're going to get a little bit of a problem there. Okay. If I wanted to rotate these and get a little bit more space, I could, but I wanted to kind of stay true to that. Now, this is where it's something like a UDIM would come into effect, because if I really wanted to get super close and run an AK texture and all this good stuff, I want all that detail in the face. So I would have just the UVs for the face, because at that resolution, you have to think about it. Why do, you're being told that when you have a seam, you have to be careful with the seam, and if you paint it and everything like that, you got to be careful. When you have 8K textures or even 4K textures, and you've got multiples of them, your ability to paint out seams you may not even notice it because there's so much resolution that it's just gonna look fine, right? But when you're dealing with lower stuff, your pixels are bigger, so therefore your discrepancies will show up a little bit more. But that's him laid out, ready to go. Now let's open up the scene we just had up. Because we're gonna do normal maps. Woo! Here it comes, normal maps. Okay. Oh, where are my seams? Oh my goodness. Okay. So laid out, ready to go. We have the high res and the low res sitting on top of each other. We will do just a simple normal map, not because it's the best map or anything. We know you've done them before, or you should have done them before. Maybe you don't anymore. I don't know. So we're going to go ahead and generate that for this. So what you're going to want to do is switch from modeling to rendering. We're going to go to lighting and shading and transfer maps. Now I have the low res selected, so by doing that, it's going to automatically load that into my target mesh, right? The target mesh is the mesh that will be receiving the shading information from the high res, okay? And there's all kinds of technical ways of looking at normals and what they do and all that stuff. We'll maybe get into that a little bit. My source mesh is going to be what I'm pulling from. So remember, when you deal with scan data, right? When something's scanned in with either photo scan or photogrammetry or actual laser scanners, that creates a really high res topology, but the accuracy of the surface is spot on. That is scan data. So when I resurface that scan data becomes a source mesh because I'm sourcing the shape. I'm building the topology, but I'm sourcing the shape because the shape is kind of a given. We did the same thing. Your source mesh was your high res head. We sourced that for shape, and we built the topology that fits that shape, right? In this case, we're going to be sourcing the high res for normal information, which computes into shading information. Right, so we're going to go in there and just hit add selected. We've got that. All right, we're going to make sure we're doing a normal map. If this says anything other than what it says, if it's a different kind of map, you can remove that map and then click on normal, and it's going to refresh it and give you something default. By default, it is going to try and put out a DDS, Dance Dance Superstar file format that is mainly for games, supposed to be more secure. I just changed that file format to a TIFF. Now you're going to want to make sure that when you're doing this, you're very familiar with sourcing of textures. You will not be submitting a scene directory, right? You're not going to be submitting a project directory filled with a bunch of wasted folders and a source images folder. What I'm going to be asking from you is a very simple submission. It's going to be a folder with your Maya file, your 2 normal maps, you're going to resubmit your hair breakdown and your evaluation form, right? And you're going to source the texture from right inside of that folder. The reason for this is Most of the time, somebody thinks they know more than what I just said, and they go, oh, well, no, it has to be in a folder, so I'm going to submit that. So they submit a folder with their Maya file in it, with another thing called normal maps, a folder called normal maps, and they put their things in there, and I open it up on my machine, I hit the 6 key, it doesn't load, and they get docked for didn't source image correctly, okay? Because it doesn't know what folder, what master folder structure it came from, the D drive, F drive, C drive, or anything like that. But what I learned from working with some game stuff is it's a nice trick. What you do is you put whatever your textures are, they are sourced and live right next to the Maya file. It makes downloading a little easier as well and navigating. And then you source it that way. And no matter whose machine it goes on, they hit the 6 key, it's going to load all your textures and your maps and everything like that. Yeah, so yep, no subfolders. It will break the connection. I've seen it work sometimes, but I still dock the points because that's not what I asked for. I need the directory to be very simple. I always like that. So basically, just keep it simple. Now, when you're building this, you may not have the submission folder built yet. Okay, if you're doing just a test, you might just be naming it something test or something like that. I've seen a lot of crazy names in here, and then they change the naming for the submission, and it breaks the connection. So whatever you need to do, make sure that it's sourced before you submit it properly so it loads instantly on my machine. I hit the 6 key, there's your normal maps. Yay, you did it right, okay? So just keep that in mind. Wherever you put it now, you might need to change it. If you're thinking, well, why don't I just build the submission folder and put it in there and name it the way it needs to be named when I'm doing this? Perfect. That works beautifully as well. If you want to test this theory, take your folder, give it to somebody else, let them open it on the machine. They should hit the 6 key. The normal map should load. If they don't, you've got a problem somewhere in there and you need to fix it. Okay, so for me, I'm just going to dump mine to the desktop just for testing purposes. Yeah, just call it a day. No. I'm going to switch map space to tangent, right? The other one is object. You may have used that in MCR or another class for objects that are just sitting there, right? Hard surface stuff, tangent, object space might be different for that, but usually on things that are going to move or organic stuff, I like tangent. We're going to go to connect maps to a shader, new shader. So if this is another thing is when people are starting to import, they're exporting and importing OBJs, and they don't save out the material information, so everything gets defaulted back to the Lambert 1. I no longer have the texture material that this built, so make sure that when you're building your final scene, that those shaders go with it. So we're going to say new shader. Go ahead and connect it. I don't want to connect it. Back in the day, we had to connect it. We don't want to connect it anymore. It's going to do it for me. It's going to build it right. So we're going to go ahead and put that in there. Let's see, Maya common outputs, map width, 2048 by 2048. Again, you could use the 1024. It's a little pixelated for an entire face, but it's not bad, right? That'll work as well. But 2048 is not going to kill us either. Let's see, sample quality. Let's just start at 4x4, right? Medium. It's a nice starting place, and it works beautiful for this class, nice and quick, easy. And filter size, 4, okay? I'm going to want it to blur a little bit, but not over blur anything, okay? Advanced settings, you don't really need to get into that unless you start experiencing any issues, okay? So we're going to leave that alone. And search depth, this is how far I'm going to go back up to the top and talk about the envelope just really quickly. It never shows the envelope for me. I'm not sure why, but it doesn't work. But if you were to click on envelope, it's going to show you a red transparent cage over your model. You want to make sure that that fits as nicely to the model as well as it can, the high res. The biggest issue that's going to happen to you or give you problems with your normal map is if you didn't build a good topology and you've got a lot of dead space between the low res and the high res, they're not fitting well. You're gonna get dead spots in your model and your normal map. You're gonna see little puddles of zero detail. Okay, so you might increase your search envelope, make it a little bit larger, a little bit smaller, but we're just gonna run with what it's set up. I think by default it's 0.08. I think. Yeah, so test that out. If it did a good job again with the UVs and the actual resurfacing, you shouldn't have a problem. Okay. So we're gonna go with that, and we're just gonna go ahead and bake it. Let's see what we get. I don't know if it's doing anything. There we go. Okay, so if this takes a long time and you don't see anything happen within a couple minutes, something's wrong. Okay, so some of the things that could be wrong. One, you got excited. It's the end of the project. You're thinking about holiday season. You didn't lay out your UVs, right? That'll bake for about 6 hours and give you nothing. And you'll go, huh, I baked it for 6 hours. I didn't get anything. What, I got to keep doing this? No, it just means that you don't have any UVs probably, and you need to find that. If you click bake and it crashes, there's probably an issue with either the UVs or there's some geometry issue. It's trying to figure out, maybe you've got two surfaces really close together, trying to figure that out. It might crash it. That's usually a topology issue, something with the objects themselves. If you click bake and it takes too long, the other thing you can check is, did I put my UVs in the 0 to 1 space? That would also cause a problem, right? Because it only bakes within the 0 to 1 for the way that we're doing it. But it should go about that fast, right? We're not, a whole body might take longer, right? With gear and stuff, it's going to take longer, but for just a simple head, we should be able to get that out pretty quick. I'm going to go ahead and just minimize that. I'm going to hide the high res, and oh, look at that. Looks good, huh? No, nothing is being shown. We hit the 6 key. We should see it load. Okay, so here's 5. There's 6. Okay, so it's just tightening up the model. Looks good. See if we have any discrepancies anywhere. We got a little bit on the lips. That could be the search depth. It might be too big. I think I have it at 0.1. If I were to kick that down a little bit and rebake, it might work out. I might try rebaking once or twice, but for the most time here, I'm just going to fix it in Photoshop. Right, Photoshop's a great application. You see here, we've got a little discrepancy in the eye. Ooh, what's that? Man, I don't remember putting any surface detail. Why am I getting all the, see the little lines as I move it? See all that? What is that going on there? Let's go look. Let's investigate. Let's bring up the high res and zoom in on it. Ooh, what is all that faceting? Oh, that's because that's the normal map information I'm pulling. I'm pulling all that shading information. So what should I do before I bake the map? You guessed it, soften your normals. Because if I'm pulling hard normal information and shading, that's what I'm going to get on my low res. Now, it looks softer. Why? Because I had a blur setting of 4 for my filter size. So it blurred it a little bit, but I can still tell that I did not do that. So what I'm going to do here is I'm going to right click and I'm going to, shift right click, yep. And we're going to go and soften that edge. Shift right click, I'll get selected, soften edge. Okay, that's going to go ahead and soften those normals. That'll fix it. I'm going to cause another issue. Let's go back into, not go to training, but this one. Now, because I have everything set up, I'm just going to go and bake it again. Just click bake. Everything's set up. I've got my target mesh. I've got my source mesh. My settings are good. I'm just going to bake it again. Check it out. That is a class today. I have my shoulder hanging up Christmas lights. When I was in my 30s, I didn't have to worry about that. Well, I put my 6-year-old up on the roof, and he got terrified. So, you know, I said, "Hang over the side. I'll throw you the lights." And he didn't want to do that. I was never afraid of heights until one day I was on a 2-story house painting one of my out of high school jobs, and it was a kind of on a little window that would have bumped out, kind of like a bay window on the first floor, but it was up on the second floor, and it had a little roof, maybe about that big, and I've got the sprayer, and I'm holding onto the fascia, which is the edge of the roof there, and I'm doing my thing, and totally not afraid of heights at all. But something happened when I turned around and I was trying to navigate the cable and then the ladder. I froze dead in my tracks, and I couldn't move for about 10 minutes. Now my other crew, they weren't there, so I'm just sitting there going, What am I going to do? If I make a move, I'm going to slip and kill myself. And ever since then, I've been afraid of heights. Man, it's weird. Like I didn't almost slip. I didn't almost fall. It was just a strange thing. I know you're thinking, that's good to know. I appreciate that bit of information while you're baking normals. But, I got to do something while it's baking normals. Okay, so we've got that there. Let's take a look. Oh, beautiful. Let's hit the 5. Cool, it's loading. Let's take look at, what the heck is that? Oh, man. Well, if you caught it, what I did was I softened the normals on the high res and I hardened the normals on the low res. Now, a lot of times when people are building their models, they don't soften the normals before they bake, right? It has nothing to do with the UVs or anything like that. What this does, or why this is happening, is this is where you get kind of technical into normal information. So what I'm going to do is I'm going to show vert normals. And you'll notice that every vertice now has multiple normals, right? So you have to kind of understand. A lot of people go, oh, it talks about light and it does whatever. That's great, but really all you need to know, not really all you need to know, but one of the things that I found important to understand about normals is a normal, basically based on light information, it tells the corner of this face to be a certain color of gray. That's all it does. So based on the light angle, it says UB 0.3725 gray. So when you harden your normals, it has to split that one normal into as many normals as there are faces around that vertice, so it can identify and give specific coloring to each corner, so it gets that nice hard. It doesn't allow the color to spill into the other face. You get hard normals. So think about those as like little swords sticking out of the vertice, right? When you have multiple swords and you go and you lay, now I'm going to put a normal map on it. What are those swords going to do to the normal map? Cut it. So now it's going to cut this image, and then it's going to try and stitch it back together on the surface.
So do you want to soften?
Yes, you want to soften those normals so it's only dealing with one. Yep, a good way to go, right? So when you see that, you go, oh man, what's going on, right? Just think about ripping up a picture and trying to tape it back. You're still going to see the lines, and that's kind of what's happening when you see this discrepancy. So I'm going to go ahead and just take off the vert normals there. I'm going to soften on this one as well. We got it still sitting right on there. We're going to go into our tool. We're just going to bake it again. All right. Once you bake it again, it should look great. Now we do have the other class getting ready to come in, so I will conclude on that. So just double check. Make sure that you are softening normals on both. You got good UVs, and baking should be simple. Okay. So if you have any questions, meet me out there on the bench, and I'll see you at 7 o'clock on Friday. No, I'm just kidding. 1 o'clock, right? 1 o'clock, 1 to 3. Yeah. Buy online if anybody's there. Okay.